plan for today is we want to try and go over chapter 4, then we'll jump over and finish, go through chapter 5. Main objectives as far as chapter 4 goes. Chapter 4 goes into a lot of language features, a lot of features of the C# language, some of which you will have seen in second semester. This will just be a review. Other ones you will probably have not. Specifically, async and await you probably haven't seen yet. So there's a few different things that we'll go through here. One is going to be auto-implemented properties. We've actually already started using those, but we'll want to review those real quickly. The next is going to be object initializers. I know that you guys spent a decent amount of time writing constructors, maybe in second semester. Fair forewarning, we're not going to write many constructors, if any, this semester. Just simply because of the virtue of how MVC is built, we usually don't need to. Now, we do occasionally write constructors for our controllers if we're doing dependency injection, and we will occasionally write them for our models if we want to initialize lists. We'll get to that when we talk about navigation properties. But object initializers will be your friend. Collection initializers is a similar thing where we can set up an array or a list very quickly. Just put initial data into there. So we're going to use that a decent amount right now. That'll trail off a little bit as we go forward because we'll be pulling more of that data from the database. We also want to make sure we talk about lambdas, which are kind of a shorthand for writing little functions. Look at the var keyword. How does the var keyword compare with the dynamic keyword? Talk a little about link extension methods. Those are all very useful. I think you got some of the introduction to that in the last week or two of C#, probably. But we'll be using those very heavily. The link is a big part of what we do this semester. And then talking about await async. So that's kind of the summary of what the goal is from chapter 4. So let's start walking through that. So for this particular project, he goes through and creates an example project. I may pull that one up that he has already built. I'm not actually going to write the code that he has in the book directly. I'll just pull it up from his code. And most of these are very short programs. So let's talk about, so he's got basic project there. So let's talk about auto-implemented properties. Okay. So first thing we see here, here's a class, here's a product class, and it's got a name, right? So we can see, okay, public class product. Inside here we've got private string name. You can tell me what that is right there. Private string name. What is that? What do we call it?
Instance variable.
Call it instance variable. What's another name for it?
Field.
A field. So those are the two common names that you'll hear for that is field or instance variable. Now, instance variable tells us a lot about what it is, right? What does that name imply? What does that word instance in there mean?
That it's declared or instantiated upon object creation?
Potentially.
Every instance of the object, it should be unique.
Sort of. We're getting there, Dalton.
That's beyond what I was going to say.
So specifically, an instance, right? I create an object, right? I create an instance of a class. I may have multiple instances. I only ever have one copy of the class, but I can have as many instances of that object as I want, right? What that means is for every object, we have a different variable, right? So object A has one place in memory where it stores name. Object B has another place in memory where it stores name. Object C has another place in memory that stores name, right? So for every object has another copy, if that makes sense, of that variable. It has its own instance. That makes sense? Now, how would that be different? Let's say I made this static, public static string name, right? We would call that a class variable. Why? Because there's only one instance for the class, right? All of the instance of the object, if it's static, share that same copy. That makes sense? So that's why we want to distinguish between instance and class variables, because there's one copy. There's another kind of variables you run into, local variables, right? How is a local variable different than an instance variable? How are those two things different?
Local variables versus instance. Local variable in terms of like object or like function parameters, those types of local variables.
Well, parameters, arguments.
Well, local
Those-
variables they're specific to a certain scope
Okay.
or a block
They're
of code.
generally block scope. So generally they start when you get into a block, normally a function or a for loop or whatever. They get kind of put in memory at that point, and then they go away whenever you leave that block, right? Whereas instance variables, they're not scoped to where you are at in the code, which line of code you're running. As long as that object exists, that variable exists. Does that make sense? So they follow the life cycle of that object. When that object gets destroyed, the instance variable goes away, right? Does that make sense? Okay. So we've got a field here, or an instance variable, and then we've got a property we manually implemented. We manually implemented the name property with a getter and a setter, right? Notice the syntax for this property and this field are very similar. What's the difference between these two? How do you know that this is a field and that's a property?
I was gonna say that one's public, but that's.
But these could have both been public, right? Both fields and this could have been private. The access modifier just says who can get to it. But both of those could be private, both of those could be public.
The getting set.
Yeah, yeah. This curly brace get and set, right? If we have this code here, it is a property. If we have it like that, is a field, right? That's a very, very important distinction, right? So if I leave off this get and set stuff, and I just said public string name, I would have another field, right? I have two fields, one with the lowercase name, one with an uppercase name. That's allowed, but that's not what you want, right? I don't want two fields that look almost identical. That's a sure recipe for getting programmers confused. Right. So inside here, I've implemented the getter, which is basically a shorthand for this method, right? So I'm going to say, well, it just returns the name. You call that getter, it just returns the name. You call this setter, it's going to say, take whatever you set it to and store it as the name, right? So this is me manually implementing those fields and the getter and setters, right? Now usually, my recommendation naming-wise, if you are going to write this out, start these fields with an underscore, and that makes it easier to tell, hey, if it's an underscore, it's a field. If it doesn't start with an underscore, it's a property. Because otherwise, that can be get very confusing really quickly.
Can you say return this not name?
You could, you don't need to.
Isn't that that's more of a Java convention, right?
JavaScript, right? JavaScript, you do have to say this.
Yeah.
The this is optional most times in C#. So generally we leave it off. Does that make sense?
Yeah.
So return this name is the same thing, but in C# we're allowed to leave it off. So we generally do. Okay? The way I'd use this object, I could say, okay, let's create a new product. All good. Call them the constructor. Constructor is not initializing anything. We're using that default constructor, right? So by default, the name is going to start out as null, right? After this line is run, name is null, right? Next thing I'm doing, I'm setting that property. So I'm going to change the name to kayak, and I'm going to go grab that property from the property, save it to a local variable. So here I'm using the getter, here I'm using the setter, so I'll end up with kayak in this local variable, and then show that to the user. Okay.
Why is it being passed into like an object?
Because of the weirdness of, so there's a lot of overloads, remember, to view. And there's particularly an overload that takes two strings and does something different with those two strings. That makes sense? So if you look at the overloads for view, you'll see one takes the name of the view you want to display, and then the second string would actually be something else. It wouldn't be the model. So the problem is the version that takes view name and then the model gets parameters or string and then object. So in order to get to take the right overload, that's what he's doing. Does that make sense? This is not a problem as long as your model is not a string. As long as your model is not a string, you don't have to do a cast. And your model generally shouldn't be a string. So that's how we would use those properties, right? We can call the getter and setter. It looks, in fact, it looks just like we're accessing the field directly, right? Because if I were to do, if I had made this field public, right? I could just write product underscore name equals kayak, product lowercase name equals that, right? So working with properties, just as a reminder, it looks just like you're accessing a field, right? Okay. So given that, why don't I just say, well, let's eliminate this property and just say public string name. Just make it a field and forget about the property.
Makes them more secure.
No. Not a security thing. Hey, Brandon. What's the purpose of these properties here? Why don't I just use a field directly? Huh? I couldn't hear what he was saying. Can you just...
Sorry.
What was the initial question?
So, I've got a field here, right? And then I've got a property. Why didn't I just make this public string name and get rid of the property? Why do I need the rigor of the property and the begin with?
You made the field private.
Okay, I made the field private, but I could have made it public.
So that you can get.
It's probably so
Okay.
Don't you have more versatility? Like you can, instead of just doing like set or get, you can, you have more functionality within the get and the set themselves. Like you can do more within those property
They are methods.
method. Yeah.
They are methods.
You can
They are
manipulate the data
methods.
inside the
So that does let me do more things, but that is part of it.
Information hiding.
Yeah, that's part of it. Information hiding or implementation hiding is the one that we really do it, is because of implementation hiding. Information hiding comes down to the access modifiers. That's why we make it private. That's why we're trying to hide information. Private public is really where we talk about information hiding. But implementation hiding, which is your hiding, how does it work underneath? That's really why, right? Implementation hiding. So talking about pillars of OOP, who can tell me what those are? Remember what those pillars are.
Encapsulation.
So encapsulation is one of those.
Polymorphism.
So polymorphism,
Abstraction.
okay. Abstraction, yep. There's one more. Has to do with parent classes and subclasses.
Oh, inheritance.
Mm-hmm. Inheritance. So these are key parts of any object-oriented language, okay? The one we're talking about right here is encapsulation. It's why we have these properties to begin with, is because encapsulation. Encapsulation is all about that implementation hiding. It's the idea of providing an interface to the user that looks all pretty and nice, and so they don't have to know all the details that are underneath, right? So they don't have to worry about, oh, you changed a little thing in how it works. As long as it looks like it's the same thing to all the rest of your code, it's all fine, right? So the reason that we're creating these properties is for encapsulation. Is to hide the actual implementation of how the data is stored in the object. Okay. So that's the reason that we have those there. The other thing to know, as soon as we get to using Entity Framework, which is what we're going to use to work with databases, when we create those model classes, they have to be properties. In the Entity Framework doesn't support fields. So we need to make sure that we're writing them as properties, not writing them as fields. This is why this part's important. Okay. Now, writing it out this way means that the property is backed by a field. Okay. It also means that, well, I start writing that, and then this is how things start growing. As I add more and more fields, as I add more and more data, I keep having to write an awful lot of just duplicated code, right? There's very little difference between this and that and that. So I'd like to reduce how much code I'm writing, right? So if we're writing out these properties directly like this, we'll be writing a lot of code, especially as we start getting to model classes that have 5 to 10 properties each, right? So we want to get rid of that. Well, the way that we eliminate that is we can take this giant class here. So we've got all the fields here. We've got a getter and setter for each. We can shorten this down to this using what we call auto-implemented properties. Okay. Now, the magic sauce of auto-implemented properties, note that I still have this get and set at the end. Get and set still means that they're properties, not fields. But I don't have to write out all that logic for the fields, right? Now, question here. So I've written these out as this. Does this inherently create a field just like up here called product ID? Is there still a field called product ID with those auto-implemented properties?
Doesn't it do behind the code? Like, when you're creating all the implements, it's actually doing that behind the scenes.
It is, but it's a random name. Important thing to know that if I just try to say lowercase product ID, there is no property by that. There is no field by that name. I can't get, those fields do exist. There's a field that backs each of these 5 as far as the code is concerned, as far as how it runs, but I cannot get access to that. There is no way to get access to those fields. Does that make sense? So if I'm writing this, important question, should I put these and also add the, what happens if I add these? I say, oh, well, let's add the fields and let's have the auto-implemented properties.
It's redundant. Right?
It's worse than redundant. It
Kind
means
of
that there's 2 places in memory that if I have both fields and auto-implemented properties, I'm now storing 2 copies of the product ID in that object. I've got one that's stored in the auto-implemented property and one that's stored in the field, and they may well be different, right? Which that gets us into all sorts of scary situations, because now, okay, code in the class is writing off the field, and what we set out here externally is the property. Nothing's behaving the way I want it to, right? So these aren't exactly, effectively this is a shortcut, but they aren't the same, right? Recognize that there is a field there, but if I want to get access to it, the only way for me to get access to it is through that property. That make sense? So once we do auto-implement properties, we're just going to write it that way, which is going to save us a lot of code. And that's kind of what we've already seen, right? The model classes that we've created already have been with those auto-implemented properties. Okay. Any questions further on this?
Yes, I needed
Mhm.
there to be some kind of extra complexity to the property, such as like it needs to do some kind of arithmetic other than just setting it every time you
Mhm.
want to change the value in it. Then you shouldn't use an auto-implemented one.
Right. If you need to do anything other than just the setter saves a value, the getter returns a value, you have to implement the property yourself.
Okay.
And there's no like, I implement the get, but not the set, or the set, but not the get. You have to implement the whole thing. So it's auto-implemented properties are all or nothing. Either you do everything yourself, or you let it do everything for you. Does that make sense? So I can't mix max and say, well, I'm going to do product ID as partially auto-implemented, partially as a field. If I want to do it as a field, I need to do it and fully implement the get and sets.
Well, what if you want to manipulate the data inside of the get and set block?
Okay? It'll let you do that.
Can you use like a full property?
It will let you do that. You may run into issues with that when we get into any new framework. So fully implemented properties don't work as well, if that makes sense, when we start working with databases. So generally speaking, when we're working with model classes that represent a database thing, it's going to be all auto-implemented properties. Whereas if we have maybe a view model, which is something we send to the view, we might do something there.
So what would you do to change, like, do what you did inside of the get block and set block? Would you just do it?
I would more likely move that logic into the controller. Generally that's what I'm going to do, is move that logic into the controller instead of having it be in the model. So upsides and downsides to that, you kind of have to take it as it goes. But usually I'm going to move that data to move that operation to the controller. As a general rule, just fair forewarning, you said about setting properties in a getter or setting them in a setter. You really let me stress this. You pretty much never want to set a variable in a getter. That's 9 times out of 10, that's a bad idea. Because the expectation is if I'm reading from a getter, I expect that I'm reading. I'm not changing data. So if you throw a curveball at your programmer and you're doing some operation when I read a variable, you're going to have all sorts of bugs that are going to be weird and hard to find. So your getter, really you want to avoid doing anything more than return value, right? Or do a computation. You don't want to actually go change variables when that happens. Now, on the other side of a setter, well, okay, so I adjust the price of an item in your shopping cart, or how many I want in that, and that adjusts the total cost of your shopping cart. Great, that's what I would expect, right? In setters, there are cases like that where I change this variable, I expect that variable to change. So sometimes in your setters, that's a perfectly valid thing to go change another variable. But in your getters, please don't, because you'll have a lot of unexpected side effects. Okay. So things like this, I generally wouldn't recommend doing something like that. Where we're saying, okay, well, we set the value, but then what we return is this plus the name. But I just want the name, and now I can't get the name anymore because you're only giving me product ID plus name. But you can see you can implement, they've implemented one property, but the rest of them implemented. Okay, so that's that. Next thing, object and collection initializers. So we've created this product object here, right? So this is what it looks like right now. Okay, product ID, name, description, price, and category. Okay, so now what we want to do is actually create an object of that type, and we want to create it easily, quickly, One way I can do it is I can say new product and then call setter. Okay, this will set up that object and create it. All properties are now, once I get to this line, all the properties have been set. All good, right? How easy is it to maybe miss something there? Notice that this is kind of now divorced from that.
Well, couldn't you use like the curly braces by the constructor?
Mhm. Mhm.
Product ID.
Yeah. So this is the, we can always use this mechanism, and there are plenty of cases where we need to use this mechanism following the setters. Right? But more often than not, we want to usually try to use what we call an object initializer, which looks a bit like this. Okay? So I say new product, curly brace, and then I can set all the setter stuff. Now, the way they're formatting this, they're just trying to get it to fit on the page. Please, 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 only do one property per line. This is bad.
Come on, that's beautiful.
2 properties, 1 property, 2 properties. Good luck getting that work with your teammates as they're changing things too.
And if it's only 1 or 2 properties, then you can maybe fit it onto one line.
Yes, if it's 1 or 2, then you can fit it onto one line. Okay. But if it doesn't fit on one line, put the properties 1 line per. Does that make sense? Because otherwise, this becomes kind of a nightmare to manage changes. So, but that's the point. So we can use this curly brace, set all that. That shortens, it does the same thing as this. There's no difference. This just shortens the code. So I'll be doing that for all the feature code examples wherever I can. Just a heads up. Okay. Collection initializers. There's something very similar. Anytime I'm working with arrays or lists, if I want to initialize an array, I can do it like this. I say string array equals curly brace, apple, orange, one. Right? What's the other way I could have initialized that? I could have said, okay, let's go string array. Say index 0 is equal to apple. String array. One is equal to plum. Oh, it'd be orange. Orange. Right, so I could write it out longhand like that. Create an array that's size 3. Put in an index 0 at apple, index 1, orange, index 2. I could write it out that way, right? Or I could write it out this way. So as you can see, that format is definitely quicker, right? Hands down, that format is quicker. And it's actually easier to maintain that because let's say I want to drop out an element here in the middle. Let's say I want to drop out this first one, apple, right? I cut that line out. Does my code work?
No,
No. Why doesn't it work?
because there's no 0.
Well, I need to do a few things. I need to cut this line out. I need to change that number to 2. And then I need to update these indexes to be 0 and 1. Right? So it's a lot easier to add and remove items to that list if I use this format, right? Now, that format doesn't work if I need to go through a loop, right? If I need to create things, build this array with code and building it with a loop, that shorthand doesn't work. That only works as long as I know the elements ahead of time. That makes sense? So I'm still going to use something like this if I need to use a loop. If I need to get the data from the database or from a file or whatever, I'm still going to do something like this, right? But I'm probably going to take these 3 lines and put them in a loop.
Does C# have any like array helpers? You know, like this ES6. You know how they came out with like filter, map.
It's all in link. So
Oh, okay.
link contains all of those helpers that you're used to,
Okay.
that you've seen in ES6.
Cool.
So filter in JavaScript is the same basically as where in link.
Cool.
There's the same thing. Select is the same thing as map. So they're called something different in link because they're using the SQL terminology, but there are methods that work the same way. So anything that you can, pretty much anything you can do there, you can do. You just have to know what method to use
Right.
in link. So that's how I could write that out. This is how I'm going to write it out as a shorthand to initialize arrays and such. Similar thing here. This also works for lists, although it's a little bit different. So here I want to say I want a list of integers. I'm going to say new list. Notice I didn't have to say new here for the array. For the array, I didn't have to say new string. I actually can say new string array. It'll let me do that. That's valid syntax too. But I'm not required to. Versus here, if I want to create a list, I have to say new list. And then create a list of, here's my integers. So both of these shorthands we'll use, especially this week, as we're kind of initially setting some stuff up, and we don't have a database quite yet. Does that make sense? So these are shorthands for creating lists and arrays. Questions there?
Is it okay to use var?
Yes, it's okay to use var. Yes, it's okay to use var. Now, one thing to know here, if I put the word var here, I do have to say new string array, because it's only able to figure out the type because it's somewhere, right? So if I say var here, I would have to say that. I can say var here and then say new list. Use var as long as the right-hand side tells it what type of thing it is. So let's actually go, I'm going to skip over extension methods real quick and we'll come back to that because var is a good one to go ahead and look at. Maybe? There we go, automatic type inference. So there's the var keyword in C#. Fair forewarning, the var keyword in C# is not the var keyword in JavaScript. They are not the same at all. They work completely different. So there's no correlation between those two. Same letters, same word, same keyword, but they behave completely different. So remember that C# is strictly typed. Remember that C# is strictly typed. That means that in general, all of your types, we know exactly, all of your variables, we know exactly what type they can hold, and they can't hold anything else, right? So if I want to say this is an integer variable, I can't put floating point numbers in there. If I want to say this is a string, well, I can't put integers in there, right? If I say this variable holds a product, well, I can't put an employee in that variable, right? I can only put something that matches that type, right? Or an ancestor at that type. So var is still type safe. What var does is it says, look at what's on the right-hand side of the equals, figure out what type that is, and then put the corresponding type there. So in this case, I can see I'm saying new product. Well, by virtue of that, what type is this variable if I'm saying new product?
Well, it's product.
Huh?
Product.
It's a product, right? So writing product my variable is the same as writing this, but I save some keystrokes by writing var. Does that make sense? I can do the same thing if I'm creating if I was creating the array. I could say, or the list, I could say var my list equals blah blah blah. It would figure it out. Or I could say var my name equals this string. It would figure out that it's a string, right? This is important. Using the var keyword is critical to a lot of stuff we do with LINQ. Because one of the things that we can do as we're creating LINQ is we'll create objects, what we call anonymous objects, without actually creating a class, if that makes sense. So because I don't have a class, I can't say it's of this type. It'll figure it out when it compiles, because it's var, it'll figure that out, but we won't know that as I'm writing the code, what type actually goes there. So var is a critical piece in there, and it makes a lot of our LINQ stuff easier. Okay. Now, there is a different keyword in C# called dynamic. Okay. So var and dynamic, not the same thing. Okay. Dynamic, what it does is says, okay, this variable can hold any type. Any type you want to. And anytime you change, I can say, if I say, erase this. So let's say, let me start with just defining the type. Int x is 5. Okay, that's valid. But if I try to say x is equal to I'm going to get compile error on that second line, right? Because I'm trying to say a string into a variable that's an int, right? So if I put var here, that's the same thing. It's just going to replace this var with int. So I'm still going to get an error on this line, right? Now, if I put the word dynamic here,
I've never seen that keyword before.
I bring it up because you need to kind of distinguish between dynamic and var, and a lot of people kind of get those confused. So dynamic, if I put this here, dynamic x equals 5, this line is now valid. The second line is now valid if that type is dynamic. So this is an int here. Okay, we put an int in there, and I put in here, and now x is a string. Dynamic allows dynamic typing, but var is still strictly typed. That's the difference. Var is strictly typed, dynamic is dynamically typed. A lot of people, when they see var initially, they think, well, you're talking about dynamic typing. No, I'm not. I'm not. I'm just writing a shortcut.
In JavaScript, you can use var to do that, to do dynamic typing.
Both var or let will let you do that. Right. var and JavaScript will let you do that. Won't complain about it. It will work just fine. No complaints from the browser whatsoever.
Is the purpose of dynamic to like limit typecasting, or like why do we have that?
So the word dynamic is in there for some weird cases where you don't necessarily know the type that's coming in. For instance, string format. In fact, remember when I do string.format, first thing I give it is a format string, and the next thing is I give it arguments, right? Well, in that case, actually, the first argument is a string, the rest is dynamic array. Because I don't know what type the rest of the arguments are. Right? They could be integers, they could be objects, they could be floats, they could be strings, and they're probably a mix of them, right? So that's a case where I might see dynamic. Remember viewBag. viewBag is a dynamic object. So if I say viewBag.prototype, viewBag.name, I've just dynamically added a property to it. Does that make sense? So, or if I try to read something from viewBag and I say in the view, well, now let's get viewBag.Celsius. Well, it doesn't know what type Celsius is because it's dynamic. So you have to tell it, well, treat viewBag.Celsius as a double, because otherwise it doesn't know, right? So that's one place where you might see dynamic is in viewBag. It's generally something we try to avoid because two reasons. It creates a lot of errors. It's a lot of extra typecasting you have to now add if you add dynamic. It's pretty error prone, as well as it's actually slower. If I'm working with dynamic types, that's always going to be slower than strictly typed types. Does that make sense? So that's just one thing to be aware of. Is var and dynamic, they're not the same thing. Okay, extension methods. So extension methods are a core thing to link, so we'll need to kind of understand roughly how those work. We won't write too many extension methods ourselves, but we'll be using them quite a bit. The other thing you need to know, let's say in your views, remember we have all those what we call HTML helpers, like HTML.textbox4, HTML.begin form, all those kind of things. Well, let's say I want to add another method to that HTML class. I can actually do that using an extension method. So if I ever need to add my own HTML helpers, I can actually do that through extension methods. So that's one good use of knowing how they work, how to implement them. Okay. So, and the other part is just, they also work with link, and you can kind of add things to link if you know how to use them. You're squinting your eyes.
I didn't know you could do that.
Huh?
I didn't know you could do that.
Yeah. So we can create our own HTML helpers, which is great. I don't use that too much, but there are times when that's helpful. So let's say I've got the shopping cart. It's just a list of products like I've seen earlier. Okay, same product class we saw earlier. So this is just contains a list of products. The name of that property is products. Okay, what I'm going to do is create an extension method here, which is going to add up all the prices of the items in that shopping cart. So just a refresher on what the purpose of an extension method is. The whole point of an extension method is add a method to a class without being directly able to change that class, right? So I may have, like, for instance, the HTML helper class. Okay, MVC, Microsoft's written that class. I can't change that class, but I'd like to add a method to it. Well, I can use an extension method to add a method to it. Or I want to say, okay, well, C#'s created the list class, and I want to add a method to all lists. Well, I can use an extension method and add a method to all lists. Does that make sense? So the whole point is making it look like it's a local method, even though it actually isn't. What it actually is what we call a static function. Okay? Now, to write an extension method, one critical thing that you have to remember, extension methods can only be written into static classes. Okay? That class has to be static. Okay? So I can't just add these to my model methods, my model classes. If I need to add a method to them, I just directly add them as a regular method.
So is everything inside have to be static, or?
Yes. So by virtue of this being this class being static, all the methods inside have to be static. Okay? So that's one thing. Okay? So you'll see that this method is static. You'll see it returns a decimal. See, it's called total price. There's something interesting going on right here. Okay? Let's look at this with just ignoring that for a moment. So it takes a shopping cart, right? Takes a shopping cart object. It's going to say create this local variable total, loop through the products, adding up the total, and then finally return the total. Okay? Does that make sense? It's a function that takes a shopping cart, computes the total, returns it. Okay? Now, the magic, let's think about static. So it's a static method, right? Static method means that you don't have to have an instance of this myExtension objects. I don't have to say new myExtension methods to call this, right? If it wasn't static, I'd have to create an instance, okay? So I don't have to call that. So normally how I would call this, I'd say myExtension methods dot total price and pass in the argument as being that shopping cart, right? So that'd be the normal way I could call that. I can still call it that way. You can still call these extension methods just like you would call it a static method because it's still a static method, okay? It still behaves like a static method. What changes is this keyword this. That's what changes it and makes it not just a static method, but an extension method, okay? So because I say this keyword this, it now becomes a method on shopping cart. So looking at whatever's after it, that's what becomes a method on. So now I can call shopping cart, call my cart, and say shopping cart dot total prices. And it looks like it's an instance method on that object, even though it's in this other class. Does that make sense? So Link takes advantage of this and adds all this method to anything that implements IONIRROL. So anything that implements IONIRROL, you can use all those utility methods on.
So that would also work for any of shopping cart's child classes as well then?
Yeah, this extension method is just, it would be on all the childs. Anything that's shopping cart or descendant of shopping cart now has total prices.
Wow. That's cool.
And it looks to you as if it's there. Now, one thing I can't do with extension methods, right? I'm creating this static class out here. I can add additional behaviors. I can't add additional data, okay? Using these extension methods doesn't let me add additional fields or properties to the original object. Does that make sense? If I need to add additional data to the property, to the object, I have to actually go change the class, okay? So, and the reason I'm doing this is because I can't change the original class, right? I'm doing this and saying, well, I can't change shopping cart. Here I really could. I could really just put this method here, right? I could really just add total prices onto that object. Same difference, right? But there will be cases where we can't change the original class, so we need to push in the extension method. This is honestly one of those things. Java still doesn't have this, and it makes me really sad. Because calling static methods is oftentimes a lot more cumbersome than being able to just add a nice extension method to it. So, let's look at how this works out. So here we're creating a shopping cart. So on the outer layer here, this is a shopping cart. I'm creating a list of products. What am I doing right here? What's this new list products? That's what we call a, we just went over this. New list, yada yada.
Oh, it's object initializer.
Close.
Collection initializer.
It's a collection initializer. Because a list is a collection. So this here we're doing a collection initializer, and then here we have an object initializer. So I'm creating one list of products. That's my collection initializer, and then I have an object initializer for each of these objects that I'm putting into it. So we're actually using both of these all in one giant expression. So I'm creating these projects, I'm creating a list of products. Okay, all good. Here's where I'm calling that extension method. So you see cart.total prices, right? Remember, we didn't add total prices to the actual shopping cart class. This is just magically being added via this extension method syntax. Does that make sense? So it looks like total prices is a method on shopping cart, even though it isn't. Now, one important thing to know, which usually people get tripped on a little bit, for extension methods, this namespace is actually kind of important. So language features.models, okay? If I have a using statement for language features.models, then these extension methods will show up and they'll work. If I don't use that namespace, it won't be able to find the extension method. That's very important to know, because if you try to write out if I try to write this out without adding the model thing, it will just say, I don't know how to find total prices. And it won't tell you, like normally it will give you suggestions, say, maybe you should put this using in. For extension methods, it doesn't give you that suggestion. Okay. Which one of that thing that means is, if you leave out the using at the top, if you leave out the using for system.link, you won't get any of the link goodiness. It'll just, it's like, I don't know where is. I don't know where first or default is. It won't suggest you that you should add system.link. So you'll need to know that you need to add that using in order to get the link goodiness. Same thing with any other extension methods you write. You'll need to make sure you have that using in there for the namespace that it's in. That's a common gotcha with extension methods. It's like, oh, you left out using and now it doesn't work. They can't find the method. So that's the one line of code that matters there, is we're creating it, making it look like a method when it's not actually a method. So applying that to an interface, let's say we take the shopping cart now and we have it implement the IEnumerable product interface. Okay? So now my shopping cart isn't going to implement this, which one of the things that lets me do now, I can do a for each now through my shopping cart. Great. But it also means I can now update that extension method to be a little bit maybe easier. So in order to implement that interface, I need to write two methods. The first one is this one, which says public IEnumerator product, get an enumerator, and returns enumerator for the products.
And that what allows you to do like sorting as well within the shopping cart? The enumerator?
I mean, I can still do it if I say shopping cart.products.sort. But this allows me to do, but this actually still doesn't allow me to do sorting on this, because in order to do sort, you have to have a list for it. There's no sort on IEnumerable. Okay. Because sorting means you're changing the data.
Right.
So IEnumerable just lets you read the data. It doesn't give you the ability to change the data necessarily.
So you could say like top.to list, and then
Yeah, then you'd have a list that you could sort. So we're going to implement the getEnumerator method. This here, right here, so this is the really part that I'm interested in. This is an unfortunate part that's just the history of C#. Right? So you guys got introduced to generics, right?
A little bit, yeah.
Got a little bit of introduction to generics, which is this greater than less than thing. So generic types, generic methods, that's what you'll see there. That didn't always exist in C#. So I think it got introduced roughly in C# 2.0. Got generics. It was pretty early in the process, but it didn't originally exist. Okay? It didn't originally exist. So all of our collections classes still have a version that is not generic and a version that is generic. Okay? We want to use the ones that are generic all the time. Okay? We want to just stay away from the ones that aren't generic. So there is an interface in here just called IEnumerable without the generic part at the end. So if I just write IEnumerable, well, that's another interface. Well, unfortunately, for backwards compatibility, in order to implement this interface, I also have to implement the non-generic one. Because if I go look at the definition of IEnumerable, I'll see that it extends the non-generic one. So I have to actually implement both the generic one and the non-generic one. So this is me implementing the generic one, and this is me implementing the not generic one. Where I say IEnumerator, see this is returning a generic IEnumerator of products, this is just generic enumerator. IEnumerable.getEnumerator, get enumerator. This just calls that method and returns it. This is all this is doing. This is saying call that method, return it, that's the end of my implementation. Anytime you implement IEnumerable, we're just going to put that in. Just copy and paste that code, save it to memory. That's always what goes there. It's always that. Because, well, I just want to use the one I wrote here. I don't need to write it again. But that's an unfortunate thing. Now, one thing you'll see here, note that this is public. If I'm implementing an interface, I generally have to make it public. Note, however, that this one here is not got an access modifier on it. Doesn't say public, doesn't say private. Okay. Another weirdness of the history, right? If you put public or private on here, it'll actually scream at you and say, you can't do that. Okay. So this is what we call, what's happening here is something we call explicit implementation. I'm implementing the interface explicitly. Here I'm implementing this interface implicitly. Okay, so this one is implicitly implemented, and this one is what we call explicitly implemented. I don't want to get into the details of the difference. But just know that's why the syntaxes are different. Does that make sense? That's why it says IEnumerable.getEnumerator. I'm saying explicitly implement the non-generic version. Okay, beating that horse to death. So now that I've got that, I can update my extension method to take in anything that implements IEnumerable product. Anything. So what that means is this total prices method now, I can call it on an array of products. I can call it on a list of products. I can call it on a shopping cart. And it works. Doesn't matter which one of those things you give me, I can go calculate the total prices. That make sense? Makes this a lot more flexible. Okay. Code in here doesn't change much. The only thing that changed is now I said for each over the products thing. That's it. For each over whatever this is, all good. Questions? Questions on that?
What did it say before? In the for each?
So let's look at what did it look like before? See, the only thing that happened is I was taking a shopping cart, and I had to say shopping cart dot products.
So now it's just taking.
Now I'm just iterating over the shopping cart effectively directly, because the shopping cart is IEnumerable product.
Okay, so if you have an extension method on a interface, it'll only affect classes that use it.
To implement that interface.
Yeah.
So I'm saying based on the IEnumerable product interface, so anything that implements that interface I can now use it, which includes arrays and lists. So list of product already implements that interface, an array of products already implement that interface.
Mhm.
So extension methods, that's one big thing that we'll see. Okay, so let's see how we might fit that in. So here we're creating a shopping cart, just like you saw before. Here I'm creating an array. Same products in both of these two things. And I can call products dot total prices. I can say shopping cart dot total prices, or I can say product array dot total prices. This should actually be product array right there. So I can add up either of those two things, just like they have a total price method. Questions?
On the top one, you could just say, instead of doing enumerable product, you could just say shopping cart product, because shopping
Yeah,
cart
this
is-
could have been shopping cart right here.
Right,
There's
okay.
no reason that that has to be that time.
Okay, I was just,
Yeah. In fact, what I would do is I just put bar here. And we figure out that it's shopping cart. Same thing
it
here.
doesn't matter because shopping cart implements the enumerable, okay, well,
It'll go figure that out automatically. So I can just put bar there. It'll figure out the shopping cart and it'll figure out all that. Same thing I can do here. I could say bar, say new product array over there, and it'll figure all that out. So let's say I want to use this extension method to do something maybe a little bit more useful. So here I'm going to say I want to create a method to filter by category. This is only going to give me back the products that are in a particular category. Okay? So it takes a list of products, enumerable products, and it takes a category. So if I say this is a sports store and I only want the flip-flops or the sandals, I only want footwear, I can say give me the list of products and footwear, and it'll give you back just the ones that are footwear, nothing else. So I'm looping through the products. I'm saying if product or category is equal to what you told me, like footwear, then give that one back. Okay? Now, this is using something a little bit special. Notice that this yield return here, yield return statement there. You may or may not have talked about that in C#. Does anybody remember what that is?
so the return will leave the for each, right? Immediately.
So if I didn't have this word yield on there,
The
This
yield
would-
will, it'll, okay.
if I didn't have this word yield on there, this would immediately finish the function and I'd just get back product, right? But what's the return type of this method? Enumerable product. So we get back multiple products, okay?
The yield allows you to go back into the for each to the next.
Yes. So yield basically pauses this function midway, returns the product, and then when you go back in the for each and ask for the next one, you'll come in and run the rest of the code. So yield says, put me on pause, send this back to whoever wants it, and then you can come back here when you want the next thing. I'll give you the next thing when you're ready.
So would this be like an asynchronous function or method?
It's not asynchronous, again, because it's not using the kind of keywords, but you can kind of think of it that way-ish. In some sense, it is sort of asynchronous because you're talking about you're running here, you're on pause, and then somebody else is doing something, and then you're coming back. So it isn't what we call asynchronous, but it is similar, if that makes sense. It's not really the same, but there's some similarity there. So this says pause it and come back to it. So this is what we call an iterator. Anytime you see this word yield in there, that means you're starting to write an iterator. And what that does is this magically creates a class. This magically creates a class that you never actually see, but takes care of some things. So there are ways that you can actually write all this out yourself. If you need more tighter control out of that, You can actually write out these iterator classes yourself. They're a little bit harder to write, fair forewarning, which is why it's nice to have this syntax to make things easy.
So when it yields, is it returning one product at a time per se?
Yeah,
in-
effectively.
In the form, and it's putting it into an item rule. Like I'm kind of just confused as to what it's
So-
actually returning.
It's returning one at a time.
Okay.
So like, can you like get something midway
Mm-hmm.
and store it into like another variable,
Mhm.
and then it keeps going and storing more while that
Right.
is stored.
So let's think about it this way. So let's say I have a list. Let's say I have a list or an array. Either way, I have to have all those items there somewhere in memory store, all the things. This iterator only ever stores the current thing. That makes sense? So if I were to have this thing return a list, let's say I've got 1,000,000 records, right? Let's say I've got 1,000,000 products in my database, right? I've got 1,000,000 products in my database, and 20,000 of those are shoes. Okay, so if I ask for just the shoes, and I say, well, let's have this return a list, I now have to have those 20,000 shoes. I have to build that array and have it in memory, right? I have to have all those 20,000 things in another array, right? That takes up memory, that takes up processing time, especially if it turns out I don't need all those shoes, right? So what this does, it only ever keeps that one item that you're ever looking at. So it never actually builds that full 20,000 item list, which means I don't need the memory for the 20,000 item list. And if it turns out that I only care about the first 10 items in that list, fine. I don't have to go through the rest of the list. I don't have to do the rest of that processing power. So the rest of the processing work. So this, using this enumerator, saves a lot of performance time. Drastically will improve the performance. Which is why Link basically uses this. Link is built with these iterators in mind.
So how would it know to stop like at a certain?
So this doesn't know. It will go until it reaches the end of the product. So it's going to just go through the products. If it gets to the end of the products, well then that's the end of the iterator. And it'll come back and say, oh, there's no more items. So the way let's look at how I actually call this, and that may fit some more things into place. So the yield return product is there. Where's my for loop? So here's my for loop here. This is how I actually am going to call it. So I'm going to say I only want to add up the items in soccer. We're going to figure out their total price. So I say, okay, loop through these products in filter by category, right? So it kind of looks like I have a list over here, even though I don't actually have a list. It looks like filter by category is giving me back a list.
Oh.
So every time I go through this, every time I go back and ask for the next product, it'll go back into that method, go find the next product that's in soccer, and then go back and forth. That makes sense?
So it's just using, okay, it kind of masks,
right.
and it's actually.
Kind of
just using-
masks what's actually
Right.
happening. So it's going back and forth. And if I were to say in the middle of this, well, I want to stop at the first product that's $100 or more, well, then it would stop at that and it wouldn't go through the rest of the list. Because you didn't call, give me the next item, right? It'll just sit there waiting until you tell me, give me the next item. So if I stop this loop early, the rest of the work just doesn't happen.
So you almost have a nested loop for each loop, in a sense, because you have one loop here, but then it's going to another.
Yes, yes. So every time I call filter by, when I call filter by category, and then I say, okay, there's an implicit interface that it's actually implementing, which has get next kind of method in it. This is implementing that interface kind of in the background. So I say, okay, I want the next product. So loop through here, till it finds one that is that category, return it. And we come back and say, okay, now get me the next one. We go in here, we run the loop from where we ended off. It's the next product that's in soccer, and we come back here. So yes, it's kind of like that there is a nested loop. Except that every time we come back here, we're coming back where we left off. Instead of going back to the beginning.
Will we ever do like an example of this?
So there may be cases when you want to do this. However, more than often than not, there are link methods that are already doing most of this.
It just seems like a helper method almost. Like,
Well, it is. That's what we
Yeah.
call this. These are helper methods. These extension methods are what we call helper methods. Technical definition of a helper method is basically a static method. Any static method is a helper method, and these are static methods. So, yes, we're really writing a static method, a helper method. That's fine. It's just that most of the ones that we need, unless we need something fairly special, most of these are built into it. So we won't actually have to write too many of these this semester because most of them are already written for us. The reason you want to know about how they work is because things like this, the fact that it doesn't run all the way through, is going to influence that performance that you write when you're using it. Right? You need to understand how that works and how to speed things up. Because, for instance, you brought up the question toList. Well, there's a method in LINQ called toList, which takes that iterator that you have and materializes it to a list. What does that mean? As soon as you call toList, you don't get any of the benefits of the iterator anymore from that point. Does that make sense? Now, so there are cases where you may want to call toList to take that item, that an iterator, turn it into a list, but there are also cases where you may want to wait to do that, right? Depends on when you want to do that. You want to generally do that as late as possible. So you have the minimal amount of array at the end. You want to have that list that you end up with be as small as possible. Okay. So using lambda method, lambda expressions.
do you want a break before we?
Let me go through this a little bit, and we'll take a break at 2. So lambda methods. So maybe I want to be a little bit more general. Remember the previous version of this was filter by category, and it could only say, okay, give me the name of the category, and I'll go find something exactly with that category and give you it back, right? Well, that's great and all, but it's not very general, right? If I want to say, give me all the products that have a price of 10 or greater, I can't use that. If I want to say, give me all the products that are in soccer and baseball, I can't use that, right? I only work for one category, and I can't look at anything else, right? So I can use a delegate to make that more general. Remember what a delegate is. A delegate is a function that I'm kind of passing around as an object. Right? Function or a method I'm passing around as an object. Okay? So specifically, here I'm saying I want a delegate that takes a product and returns a boolean. So I want a delegate that takes a product, returns a boolean. I'm going to say func product boolean. Okay? So the way I'm going to use that is here. Remember what was here previously. I would say if prod.category equals category parameter, then do this. Here I'm saying if selector parameter, if this delegate returns true for the product, then I'm interested in, right? Well, this one lets me pass in whatever function I want. Whatever crazy logic I want to put in here for deciding which products I'm interested in, I can now do that. I just need a function that says, okay, give me a product, and then I'll tell you whether or not I want it, whether or not I like it. Yes or no? So how does this work in print? How do I hook this up now? So now I'm going to call filter, and I'm going to pass it in this category filter. So I've created a method here, and this is the long form of it. There's a shorthand, and we'll look at that in a second. So I'm going to create a method here. I'm going to create delegate, takes a product, I'm going to say return product.core category equals soccer. It's actually the same, right? So I'm going to say I'm only interested in products that are in category soccer. Questions on that? You can see that syntax is a little bit long, a little bit verbose. We're not going to use that syntax. Because what we want to use instead is a lambda function, which looks like this. So we say, create this function, product bool, and here I'm going to use what we call lambda syntax. It's got a little arrow here. So what's to the left of the arrow are the parameters to the function. Those are the inputs. And what's to the right of the arrow are the outputs. So you can think of this inputs and then outputs, right? What does it take in? What does it give out? So it takes in a product, and it says product.category. If that equals soccer, return true. Right? So the right side of this is just an expression. It returns true or false.
It looks like JavaScript.
Well, because JavaScript uses the same syntax. It's the same syntax. Lambda syntax is the same between JavaScript and C# and .NET. Now, one thing to know for writing the lambdas, I would definitely recommend taking a note on this. So depending on how many parameters that you are getting into this lambda, changes how you have to write the lambda. Okay? So if I have 0 parameters, I need to write it one way. If I have 1 parameter, I need to write it another way. If I have more than 1, I need to write it another way. Okay? The parameter, if it takes more than 1. So here, if I want to say it only takes 1, this would be a function that takes no parameters and returns 5. Okay? If I want to take 1 parameter, I might say x arrow x plus 5. Okay? So note here I have parentheses. Note for 1 parameter I don't have to put parentheses in there. In fact, they're optional. So I can actually write it either that way, or I could write it as parentheses x plus 5. Both of those are valid. So if it only takes 1 parameter, the parentheses are optional. If it takes 2 parameters, the parentheses are required again. So the only case I can leave them off is if I have 1 parameter. So I take x and y, I say x plus y, or something of that sort. Does that make sense for writing lambdas? What's on the left is the parameters you're taking in. What's on the right is what you're giving out. And the parentheses, again, the only time you can leave them off is if there's exactly 1 input. But the reason that exists is most of our lambdas have 1 input. Most of our lambdas fall into that case where we have 1 input and 1 output. That's the most common case. Okay? Yes?
Is there anonymous methods or functions that
Well, this is basically what we call that is basically an anonymous function right there. I never gave this a name. This function really doesn't have a name. I put it into a variable called category filter, but the function doesn't really have a name, right? There's no name for that function. In fact, I could have put this directly in here. I could have said directly here, product, arrow, product category equals soccer. I don't actually have to put that in a variable. I don't actually have to put that in a local variable if I want to, which, like that. That's usually how we're going to write that. Not even put in a variable. Okay, now I could also extend that. So I can say product category soccer. I could also easily extend that and say, well, I want the products that are in soccer, or they have a price of greater than 20. Any Boolean I want to put to the right, I can. So now this becomes a very, very general filter function, right? In fact, same filter function that you used to in JavaScript. Same thing. We've just implemented it ourselves.
Same exact syntax and everything.
Yeah, no difference.
So when should you actually use methods?
What do you mean? When should you actually write methods? Well, we have to write one for every action.
You can just use this stuff.
No, for every action, every page, right? Remember, we've already written methods for those pages. We do still have to write methods for that. So if I want, like, remember we had an index for the get and an index for the post. We still have to write those methods. But yeah, no, we will be writing very few methods outside of what goes into the controller. Generally speaking, we'll have actions, and we may have some additional methods in our controllers for utility things. Specifically, like there may be code that's used in more than one action. Then I want to break it out. But no, I don't need to write basically any methods on most of my model classes. Okay, so any questions further on Lambda expressions? Do you see what's going on there? I'm sure you'll run into some hiccups when you get your hands on it. I have put out there's homework, I think it's 1D, which is over chapter 4. So as you go through that, there will be some questions about lambdas and this kind of thing. If you have questions on those, go ahead and call me over. I'll help you through that. Just because we're not quite at the point where we can put this into practice yet, but we'll put this into practice sometime next week. Is the plan. Okay, so we talked about the var keyword, anonymous types. So usually when I create an object in C#, I have to create a class for it, right? Usually I have to create a class for it. So if I want a product, I need to create a product class. Well, sometimes I just want to create objects out of the blue without defining a class. You're following me? So this is still not dynamic. Fair forewarning. This still generates a class. C# still creates a class in the background. It's just what we call anonymous. It has a name. It's just a randomly machine-generated name. So it's still var, that's still strictly typed. It's just that I don't know the name of that class. And it will probably be different every time I compile the software. Be a different number. So I'm creating a new object. I'm giving it a name property. I'm setting that to MVC. I'm setting the category to pattern. Now I have a new object. It's got 2 properties. I can work with it as that without having a class. Okay. That's a useful tool. Okay. Next thing. So let's put this into practice here. So here I'm saying I want to create an array of things. I'm going to say new array. Note that I haven't specified the type of this array actually. I haven't said this is an array of yada yada. It's going to figure that out, but it's an array of something. Var, name is MVC, category is pattern, name is hat, category clothing, name is apple, category fruit. So I now have this magically array created with object initializers and a collection initializer and anonymous types. And now I can start doing logic with that array and start looping through it and say, okay, well, let's start, just put all these together, separating by a space. We'll take the name property and just put them all together. Great, I can do that.
Do you have nested objects?
Nested anonymous objects? Absolutely. Absolutely. Yeah. You nest this out however deep you need to. Now, one downside of this. Remember when I create a view, I have to, at the top, say what class it expects? I have to tell it what model class to expect. So I can't pass an anonymous object like this. I can never pass it actually to my model, pass it to the view as a model, because I don't know what class it is. So if I want to pass something to the view, it does have to be a type I've defined. That makes sense? So the only place I can actually use these is in between in the controller. I'll create them, and then what finally goes to the view will be an actual object, an actual class. That makes sense? Because otherwise the view wouldn't know what class to expect. So we'll see these in our controllers, but we won't actually pass them to the views. We'll just kind of make them and go, and then they'll go away. Okay. Let's take a break at this point, and we'll come back and look at link. Okay, so we're back. So what we'll look at next is link. Go ahead and turn off one of those lights. There's a request there. So what I already have here is I've got a home controller, I've got an index method, and I'm creating a list, I'm creating an array of products, right? So I've got kayaks, life jacket, soccer ball, and my corner flag, okay? So the first thing I want to do is I'm going to actually want to set up a view so I can see this data, right? I want to set up a view so I can see this data. So I'm going to say, let's return products, okay? I'm going to turn products as my model. Okay, let's go over to the views folder. I'm going to create a new view, add view, and this is going to be called index, just as we're used to. Uncheck use a layout page. Okay, so I've got a basic index page. Now I want to tell it that it can get a list or an array of products, right? So in order to actually do that, I want to tell it that it can take enumerable product. This would be language features dot models dot product. So that's how I'm going to specify that it can take an array or a list of products. Questions there? Remember that both of those things implement that enumerable interface.
Is that what we're going to be doing in the next lab with the roster?
Yes, with the roster you'll want to have a page that lists those team members or those people that are on the roster. So your view, your index view, will need to have an interval of people. Okay. So we're going to have an interval at the top, and then what I want to do, I'm going to give this little H1 products. And then I'm going to start a div. We'll just have a container there. And I'm going to list, actually let's do that as an unordered list. Or no, I'll do it as a div. So at for each in the model. So remember, this is now enumerable. Because of that, I can now loop through it. I can treat it just like it was an array or a list. That make sense? So I can loop through and show each of these. So I'm going to say, okay, we want to show their names, and I want to show all their fields. So throw this off to the side so I can see what fields there are. So I want to say I want first a div. I'm going to say ID. Product ID. I want their name. I want their description. I want the price, and finally I want the category. Obviously, I'm not doing anything with Bootstrap here. It's going to look kind of ugly, but let's just go take a look at what this gives me, because this is a start. Okay. All right. Well, so I can tell I have all the products. I might want to put a little bit of a border around them just so I can see individual products. So let me just go put that in there. Put a div around there. Close the div up. So div out in there, style, border, one pix, solid, black, margin, so I can see maybe more clearly the products that I have. Right. We can make that look a lot prettier. You can go in your Bootstrap and make that look a lot prettier. So you can see the basics of, okay, I can see the data now. Right? Even if it doesn't look pretty, I can see the data now. Yeah, so main tool there, I've changed the model. I've used a for each loop to loop through the model. And then you can see product.product ID. I'm not doing model.product ID. I'm doing product.product ID. And obviously if I called this something different, I need to use that name there. Right? So when you're doing people, this might be person, 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 person. Or item, item, item. Yep. What?
You scroll
And don't worry about copying this code down. I'll give you a copy of it when we're done. But does that make sense? So that lets me show a list of things to the user. And that's typically what we'll show on the index page. Okay. So what I want to do next, here is my goal. I want to find the 3 highest priced products and pass them to the view. Okay? That's my goal. And this I'm going to do first. I'm going to do it without link, and then I'll show you how to do it with link. Okay? So how would we do this without link? How can I find the highest products, highest priced products?
Make an extension method?
Okay, I don't actually need to create an extension method.
You would loop through the products and then as it loops through, it creates a benchmark on which is the highest and places those into a separate list that gets returned.
So you want to loop through it, find the biggest one, and then find the next one, and find the next one, and find the next one? I'm going to try to do something a little bit simpler than that.
I mean, it's just like, are we gonna write it knowing that there's only 4 products?
No. Scott?
SQL or Git?
Let's think about this process. So I want to find the highest priced ones, right? What might be a sensible first step? Well, maybe a sensible first step is to sort them by price. So let's start with that. So let's start by sorting the array by their price. So if I say products I'd like to sort them.
I remember there's something to implement into product class.
Not
but I
comparative.
forgot what it is.
Right? Isn't that comparative?
Yeah,
So
comparative.
here's the thing. So an array does not have a sort method. A list does. So I'm going to go ahead and just change this first line here to be a list. So new list of products. That's going to make life a lot easier. And remember, because I'm taking IEnumerable on the view, it doesn't break the view. The view doesn't care whether, because both of those are IEnumerable, it doesn't care whether it's a list or an array. So I'm going to go ahead and sort the products. Now, if I just tell it to do this, it's not going to sort it the way I want it to. I need to tell it how to sort it. So I'm going to add a lambda there, if I remember right. We're going to tell it to sort it by the price. Okay. I think I have something not quite right. Go to definition. Oh, it takes an iComparer. So to implement an iComparer, or no, comparison. Go to definition, delegate XY. Okay. It takes the two things you're going to compare, and we're going to say, figure out which of those is bigger. So we say, actually I can do this as just x minus y equals beef. No. Okay. Long form. So So give it a nice long method. And say if x is greater than y, turn 1. Oh, it's not price. And let me just check that because I think I might have my negatives and my positives flipped. So the highest one, okay, there we go. So now it's sorting it by price because you can see the lowest price item, 1950, highest item, 275, 1950, 340, 34, 48, 275, which, looking at here, wasn't the original order it was in, right? So originally it wasn't sorted by price. So now it is. So the way I've sorted it by price is I've given it this method. So I've said if it's greater, if the first one's greater than the second one, give me positive, negative, 0 says those. That's kind of how you would implement the iComparable interface. A little bit shorthand maybe from what you saw last semester, but that's what I have to write. It's still kind of ugly, right? It's still kind of ugly. And I have one thing that I don't necessarily like here, because really, maybe it's still not, it's sorting it, but it's not sorting it in the way I want it to be. It's sorting it from the smallest to the biggest, right? I want the 3 most expensive things, right?
Can you just switch to the 1 and the negative one?
That's one option. And I'll come back to that because that's the better option, but there is another option.
Isn't there a dot reverse method?
There is. Okay, so let me go through these 2 different ways of solving the problem because it's worth seeing both. So products dot reverse.
That basically multiplies every index by -1.
It doesn't. That's not what it does. So if I reverse it, I've got it in the outer order, right? That's one way to do it. But when I reverse it, what it's actually doing is it's going through the array that's already been sorted and moving them around. It's swapping the first and the last, and the next one, and the next one, and the next one. So that's a lot of memory accesses to do reverse, right? If this was if this array was 1,000,000 elements long, I have to write to memory 1,000,000 times to do that one line of code to reverse it. Does that make sense? So that does work, but you don't want to use it because it will be very slow. Okay? So yes, the way I'm going to fix this is I'm just going to flip these negatives and positives instead. So if I run that now, it's flipped, and yeah, I didn't have to do a reverse. But remember that there's both of those options, right? The flipping the sign is always faster than reverse if you have the option. You may not always have that option, but if you can flip the sign, flip the sign.
So is the sort method looking for like 1, -1, and 0?
Mm-hmm. Well, it's looking for positive, negative, and 0. It could be -5 and -2 or positive 50. The number actually doesn't matter. It just cares about whether it's negative or positive. And specifically, normally, that tells it, is this before or after? So in this case, I've said, if the price of the first this of x is greater than the price of y, I want it to be here before, I want x to be here before y. If x is less than y, then I want it to appear after y. So it's just saying, is this before or after the other thing? Okay. So that's one way to get it sorted first, right? And then the next thing I want is just the first 3 items. How can I get just the first 3 items?
Return a range.
Huh?
Return the range.
A range?
Yeah.
Would you use link in this case?
I don't want to use link yet. You had a hand up, Scott? I don't want to use link yet. There is a way to do this in link.
-3, or return like -3. Is that? Maybe not.
So this is sorting. I'm going to have to do something next.
Could you use the yield return in this situation? If you're like gonna loop through like the existing products
Mm-hmm.
and return the first 3,
Okay.
but it's a yield return.
Well, let me do this without a yield return just to keep it simple.
Fair enough, yeah.
Let me do this without an iterator just to keep this simple. So I need to basically, the easiest way to do this is to make a copy of the array and just grab the top ones that I care about, just the first 3. So let's create another array. We'll call it top products. And we'll say new list of products.
Then you can use a collection initializer.
I could use a collection initializer. I actually won't, because what if there was only 2 products,
Yeah.
right? I could use a connection initializer, but that wouldn't handle things if there was less than 2 products. So what I'm going to say is for int I is equal to 0. We're going to start at 0. I is less than 3. And I is less than products
You need
dot count.
I think you need a semicolon instead of the ampersands.
No.
I,
Because he has a double.
no, this is right. So what I'm saying is start at 0, start at the first item, loop through. I want to get up to 3 things, but I also don't want to get more than what's in the list, right? So if there's only 1 or 2 items in the list, I won't go past 3. So if there's 3 or more items, I'll only go up to 3. That's where this is at. But if the list is shorter than 3, this other check will keep me from going beyond the length. So I'm going to say give that an and. And then I'm going to say, okay, so 2 top products. We're going to add. And I'm going to add products I. So I'm going to loop through those. Just grab the top 3. Pass it down to the motor. $275, $48, $34. Okay. It doesn't matter how many products there are, whether there's anywhere from 1 to infinity, I've got the top 3. Okay. Huh?
What is the I less than products dot count? Is that
I let
Accounting for if it's less, if there's only 2 products. in the
right.
list.
If there's only 1 or 2 products, I want to stop early. Right? So if I only had, if I say let's remove these others, right? It's only going to get 0 and then 1.
okay?
If I didn't have this here, it would error out when it got to the next one to say there's no index 2. Right? There'd be no index 2.
That makes sense.
So this is the way I can write it without using link. Okay? Without using link, I can do this. I can solve this problem. Okay? However, it's not necessarily a lot of code to write, but when you start writing this again and again and again and again, it starts to get pretty tiresome to be writing all this over and over again. So what we want to use is link to kind of ease this up. And in fact, link's actually going to be faster. Link's actually going to be faster for this particular problem. So what I want to do, I'm going to say var top products, because at the end of the day, I still want to produce that list that I can pass to the view. So the first thing I need to do, remember, was sort it. Okay? I still effectively need to do that first. So products dot order by, and I'm going to actually say order by descending, because I want to go from the highest price down to the lowest price. Order by descending. So that's that first step where I needed to sort it. And then I'm going to say take and grab the first three. That's done everything that I just did here. It hasn't turned it actually into a list. This is still actually in an iterator. If I wanted it to be in a list, I'd call toList at the end here. And now I've done everything that the other did in a lot less code.
So does that order by descending, does that just take this sort method?
So it will go and figure out, it will go do the order. It actually does the order though on a copy. So this does it on the original array. Order by descending actually does it on a copy of the original array. Let's just test that, make sure I get the same thing. And I do.
Just to clarify the lambda expression that you have.
Yep.
The X is representative of one product in your list
Yes.
of products. Yeah.
X represents a product because I'm iterating over
Over a list of products.
a list of products. If I was iterating over a list of people,
And it represents a
then
person.
X represents a person. Not everybody, different people have rules about what letter or what kind of name they give those. I tend to stick to X simply for the reason that if things change where the class or whatever gets renamed, then I don't have to go back and change that. There's no expectation of like this matches to the first letter of a class. Because if I go and say, well, this originally was category, and the class was named category, and I renamed it to product category, well, then I maybe have to go through and change it from C to like PC or whatever. Well, I don't want to go do that. I don't want users I don't want developers to make an assumption about the name of the variable meaning the type of thing it is. So I just use X.
Okay.
So what is the lambda like doing here?
So order by ascending needs to know how to order it, right? And I'm telling it to order it by the price. Telling it to order it by the price of the product.
So it's saying by the price of each product.
Price is a number, it knows how to sort numbers. It doesn't know how to sort products, but it knows how to sort numbers. So I just tell it what number to sort by. Okay. So link has a lot of methods like this and becomes very, very useful. They'll show you a different method here. This is what we call the SQL-like syntax of doing this. I prefer to stick to the functional syntax most of the time because it ends up being easier to work with in the long term. But we'll see a little bit of the language syntax come up. So the way that this works, the other way that they've written this, is they say from match and product. So match is a variable that they're just naming. And then we're going through the products array. We're saying order by the price descending. Similar to what you saw, I did order by. And then select mu. So they're creating an anonymous object with properties name and price. And then they're going and doing stuff with it. Now, the way that they're limiting the 3, they're not using the take method, they're doing a counter here. You can use the take method off of this, because this syntax still produces an iterator. This still produces something that's INL, this link syntax. But the thing to be aware of, there's the query syntax like that in link, but there's also all the methods. Pretty much everything you can do with the extension methods like I did, just like you do here. So here they have an example. They're doing the same thing with extension methods. Products, order by, take 3, select the name and the price. Okay, so this is a list. I would definitely recommend having this handy. Here's a long list of, this is page 89. I would recommend you maybe print that out. In fact, actually, I'm probably going to give you the handout I made last semester, which has a lot of these in a little bit of a different format. But I would definitely recommend printing out page 89 because it will be worth having it handy. We'll use these enough. So, looking at all these methods that are here, what's their format? So this is the name of the method. They're kind of telling you what it does, and then there's this column called deferred. Okay? So most of these methods in link are deferred. They're deferred because they're using iterators. And what that means is when you immediately call them, they don't actually execute. They don't actually execute at the time that you call them if they're deferred. They only execute at the time you call them if they're marked yes. Then they happen immediately when you call them. Okay? Now, what does that mean for us? That means we want to call the deferred ones as late as possible. So we have the least possible data that we're working with. And so that most of this work can happen in the database on another computer rather than on our actual website. So the ones that are not deferred, that one's actually, I think, a misnomer. Yes, is order by is definitely deferred. I believe reverse is deferred as well. Oh, sorry. The ones that are not deferred. Deferred no is, okay, it's not waiting. I've got those backwards. Deferred no is the ones that don't wait. So all says everything in here matches this predicate. Like, remember the predicate that I put in there? They say it's soccer and it's greater than 20. That's the predicate. That lambda expression that we put in there takes an item, returns a bool. That's a predicate. So any of these that take a predicate, that's what they're talking about. Take an item, return a bool. So if that predicate returns true, for everything in that list, all will say yes. All says, does everything match the predicate or not? And he says, is there at least one thing in here that matches the predicate or not? Contains says, oh, is there this specific thing in there? Contains is a lot less useful, to be honest. That would be, hey, I've got a list of strings, and I can say, does it contain the string ABC? Working with products, that's a lot more cumbersome. That's not as, doesn't work quite the way you would expect. So I wouldn't generally recommend contains if you're not working with something like an array of strings. Count says how many things are in there. Now this is count with parentheses, okay? There's two counts. There's count, which is a property on the list class, and it doesn't have parentheses, because it's a property. So dot count will just go look in memory and say, what's my count? Read that variable, give it back to you. Okay? Count with parentheses is a method. So if I say product dot count, no parentheses, that's property, products, dot count. That is method. This one just goes and reads the property, we're done. Easy, fast. This one with the parentheses will actually loop through the whole list of products and figure out the count that way. So no loop here, loop here. If there's 1 million products in your list, how many times slower is the second one going to be? Huh? At least 1 million times slower, probably more.
Wait, can you repeat that again? Products that count as what?
This one just reads, this first one is just going to read the field and return. The second one is actually going to loop through the list and count them up. So yes, if you've got 1 million products in that list, it's going to be at least 1 million times slower. It might easily be 3 million times slower. Longer to do that. Okay. This would be nanoseconds. This could take seconds to run that one line of code. So you want to make sure that you're careful about which one you call, right? We want to prefer this one as often as we can, and run that first one as often as we can. But there will be cases where you need to run that one. But try to avoid it as much as you can. First is just going to grab us the first item in that list. Okay? Now, important distinction. There's two of these things here. First or default. Okay? If the list is empty, first or default is just going to return null. So first is going to return, either of these are going to return the first item, but if it's empty, first or default returns null. First throws an exception. First throws an exception if there's nothing in the list. So which one do you think we want to use more often? First or default? Usually we want to use first or default so we don't have to deal with those exceptions. Because usually null is the thing that makes sense there. Is say, okay, give me back null. Last is a similar way. Last says give me the last thing in the list. And if there's nothing in the list, then it throws an exception. Last or default either gives me the last thing in the list, or if it's empty, it just gives me null. So those give me null, and these are going to give me an exception if it's empty. Max gives me the highest thing in the list, and min would give me the lowest. So I can easily use those to find, hey, I want the highest price or the lowest price. Now that doesn't work for giving the lowest 3 or the highest 3. That's where I need to do that take structure, order by and then take, if I need more than one. But if I just want the highest price, just want that value, then I can use that method. Order by is going to sort it in ascending order, depending on what property I tell it to. Order by descending is going to sort it in descending order. I can then reverse it. I can say select. Select is a way of saying I just want some of the properties from the object. I don't want all the data. So maybe I have an object, a model class that has 20 properties, but for whatever I'm doing, I only need 2. So I can use select to only grab this 2 that I'm interested in instead of pulling all that data. Single is very similar to first. It says, grab me the first item as long as the list is exactly one item long. If the list is shorter than one item or longer than one item, then it throws an exception. That makes sense?
Well, I think you skipped over select.
I am going to skip over select many because I don't think it will come up this semester. Select many is honestly one I've never used. It is something that's occasionally helpful, but it's a very weird case. So you probably won't run into select many, to be honest. When you do, we can look at it. You probably won't run into it. Signal or default is similar to this, it just doesn't throw an exception. Well, it doesn't throw an exception in one side. So this signal throws an exception if there's less than one, or if there's more than one. Signal or default throws an exception if there's more than one, but returns null if there's 0. These are kind of neat. This is if you're being very strict about your code. Skip says skip over the next X items. So if I want to say skip the next 5 items, I'm going to say skip 5. Where might that be useful? Paging, right? So if I have pages of 5 items per page, I can say skip the first 10 items. That will get me to page 3, and then take 5, and that will give me the 5 items for that page. So I can combine skip and take to get paging. Again, I'm going to skip over skip while, because this is not really one that's useful. Sum is going to give me the total. So I want to say, give me the total price of everything in your shopping cart. I just say, take shopping cart, do sum, say sum of price. Cool. I've got the total price of everything in your cart. Take, we've seen. Then there's a few interesting ones here. So toArray is going to take it, run the iterator, turn it into an array. toDictionary is going to turn it into a dictionary. toList is going to turn it into a list. The only one of these 3 that we care about is toList. I don't really have it's virtually never that you want to do toArray. There are occasional uses for it, but virtually never. It's pretty close to never. Same thing with dictionary. It's very rare that you want to turn it into a dictionary. It's very rare that you want to turn it into an array. Generally, you want to turn it into a list. And then finally, where, that's our filter method. So where we can say, hey, anything that matches this predicate, which reminder, that's take an item, return true or false. Anything that matches where that predicate returns true, give me those items. So if I want to search for all the products that are in a particular category, I can use that. Let's go over that real quick, because that is a very, very useful method. So let me comment this out. And I'm going to say var products is equal to, what's the category that, okay, so category soccer. So where, I'm going to say products dot where, and that looks like this. So where x dot category so that way I'm just going to get the 2 products that are soccer. All done. So there are a lot of methods in this list. Again, I would recommend printing out page 89 and playing around with all of them so you can understand them, seeing how they work, because we will use those. Okay, so one thing here about the deferred queries. You saw some of those are marked deferred. So let's say we have this set up here. So we have an array of products. When we say, okay, run this, order by descending, take and select. All of this stuff is deferred. Happens later. Okay? Here I'm gonna, on this line, I'm gonna say change product to, which one's product 2? It's the soccer ball, right? 0, 1, 2. So change the name of the change soccer ball to be Stadium 796, right?
No, it's found products.
Yes, because this is deferred. This change is happening right now. This hasn't happened yet. So when I run this down here and I say I want to find the top 3 products, the products with the highest price, notice that this one is very high. This one's going to come out as a search result because this actually happened first before this happened, even though they're in a different order in the code.
So why is that? Again?
This is deferred.
Right.
All of this stuff, ordered by descending, take, select, none of that happens until I actually iterate in this for each loop. I'm just setting it up here, telling it to happen later. It doesn't happen until I do found products here, until I loop over. Does that make sense?
If you're mixing deferred methods with methods that aren't deferred,
As soon as I call one that's not deferred, as soon as I call one that's not deferred, the whole thing is, it happens right then.
okay.
Everything happens right then. Everything up to that deferred non-deferred method happens then. So if I say all, or to list, it'll immediately happen then.
So it basically doesn't update until it's interacted with.
And yes, until you tell the link query to go, it doesn't do anything. Until you say, okay, now I'm ready for the data, it doesn't actually get you the data.
So that's triggering by that for each loop.
Yeah, so it's for each loop. As soon as I loop over it, now I'm starting to ask for the data. Which is, at that point, is where it'll run the query. Here's an example of using sum. So we're going to say sum the price. That's going to give us the total price of all the items in that list. So it's going to add up all that. Now, we're 303. Okay, any questions about link? I'm sure you'll have some more questions as the weeks go on. Okay, but no questions right now. So, next item of inquiry. We want to talk about something called asynchronous methods. Okay, these use 2 keywords called async and await. What I want to pull up here, there's 2 videos from a good person I follow called Mosh. He's put these out. These are actually about Node, but the way it works in Node kind of carries over to how it works in C#. So he gives a good intro to it. I'm going to kind of use his intro, and we can talk about it more and how it applies to C#.
That section we used a simple array to manage the list of our courses. In real-world applications, however, instead of using So in the last section, you learned how to build RESTful APIs using Express. But in that section, we used a simple array.
This is the wrong one. I want to start with. There we go.
So earlier I mentioned that Node applications are highly scalable, and this is because of the non-blocking or asynchronous nature of Node. What do I mean by asynchronous? Let me give you a metaphor. Imagine you go to a restaurant. A waiter comes to your table, takes your order, and gives it to the kitchen. Then they move on to serve another table while the chef is preparing your meal. So the same person can serve many different tables. They don't have to wait for the chef to cook one meal before they serve another table. This is what we call non-blocking or asynchronous architecture. And this is how Node applications work. The waiter is like a thread allocated to handle a request. So a single thread is used to handle multiple requests. In contrast to non-blocking or asynchronous architecture, we have blocking or synchronous architecture. Let's see how that works. So back to our restaurant example. Imagine you go to another restaurant, and in this restaurant, a waiter is allocated to you. They take your order and give it to the kitchen. Now they're sitting in the kitchen waiting for the chef to prepare your meal. At this time, they're not doing anything else. They're just waiting. They're not going to take an order from another table until your meal is ready. This is what we call blocking or synchronous architecture. And that's how applications built with frameworks like ASP.NET or Rails work out of the box.
So you can kind of see that you see where the problem is, right? With synchronous, the waiter's just sitting around in the kitchen drinking some coffee, while he could be serving other customers or filling up your drinks. He can't do anything. He's just sitting there around and waiting. The way this factors into real world, that kitchen is basically our database. It takes time to get anything from the database. We don't want to wait around for it. So whereas this waiter, that's the server, that's our resources that we can potentially serve different users with, right? Think of all those tables as users. Think of that kitchen as our database. We want to be serving as many users as we can. So ideally, we want to write our application to be asynchronous so that we can handle a lot more users at once.
So when we receive a request on the server, a thread is allocated to handle that request. As part of handling that request, it is likely that we're going to query a database. And as you know, sometimes it may take a little while until the result is ready. When the database is executing the query, that thread is sitting there waiting. It can't be used to serve another client. So we need a new thread to serve another client. Now imagine what would happen if we have a large number of concurrent clients. At some point, we're going to run out of threads to serve these clients. So new clients have to wait until free threads are available, or if we don't want them to wait, we need to add more hardware. So with this kind of architecture, we are not utilizing our resources efficiently. This is the problem with blocking or synchronous architecture, and as I explained, that's how applications built with frameworks like ASP.NET work by default. Of course, in ASP.NET, it is possible to use asynchronous architecture, but you will have to do extra work for that. In contrast, Node applications are asynchronous by default, so you don't have to do anything extra. In Node, we have a single thread to handle all requests. When a request arrives, that single thread is used to handle that request. If we need to query a database, our thread doesn't have to wait for the database to return the data. While the database is executing our query, that thread will be used to serve another client. When the database prepares the result, it puts a message in what we call an event queue. Node is continuously monitoring this queue in the background. When it finds an event in this queue, it will take it out and process it. This kind of architecture makes Node ideal for building applications that include a lot of disk or network access. We can serve more clients without the need to throw in more hardware. And that's why Node applications are highly scalable. In contrast, Node should not be used for CPU-intensive applications like a video encoding or an image manipulation service. In this kind of applications, we have a lot of calculations that should be done by CPU and few operations that touch the file system or the network. Since Node applications are single-threaded, when performing the calculations to serve one client, other clients have to wait. And that's why Node should not be used for CPU-intensive applications. It should only be used for building data-intensive and real-time applications. Okay, enough theory. Next, I'm going to show you how to install Node and build your first Node application.
So does that make sense from sort of the analogy why we're going to do this? So if we just write things as we would normally with action results and all this stuff, we'll only be dealing with one customer at a time, and everybody else is going to wait until that customer is done.
What happens if you got too much going on at one time?
At some point, you do need more than one server. Yes, at some point, one server is not enough. So you will have to scale out to more servers. And that's true with Node as well.
Okay, so it can't be both asynchronous and have more than one thread?
It can be both, yes. It can be both. But really what that means is we run up more than one server, basically.
So does it slow the tasks, like individually? Like, does it speed up one task or slow the other tasks?
So here's the trick. So most of the time, we're waiting on the food to cook. 90% of the time, the stuff that we're doing on our servers on the back end is just waiting for the food to cook. Whereas all the stuff that we're running on the CPU, all the stuff we're actually running in our server, it may run in under a second. It may run under a second. Whereas all the stuff we need to do in the database, that may be up to a minute of work that needs to happen on the database side. Does that make sense? The trade-off is we actually need to do very little processing in our code. Most of the processing actually happens on the database, which means that if we are sitting around and waiting, that's a whole minute that we can't serve customers, versus I can spread that out and have the database doing working on all those processes while I'm just going around and serving customer here, doing the little short pieces that I need to do for each customer, like refilling their drinks, right, in between. Does that make sense?
So kind of creates a queue on the server side for
Yes.
all the requests?
Yeah, it does end up creating a queue. So we end up with a queue of like all the different things that are happening. Well, that happens either way. A queue happens whether we have synchronous or asynchronous. It's just that queue gets handled more efficiently if we go with async. Does that make sense?
Yeah.
So we can handle more people. We'll get into using that async, and we'll show you a little bit. I'll show you a little bit of example of how we might put that into practice. But basically, if we don't use that, we have one long run. If I have one user that's doing something really slow, then everybody else has to wait for them. Whereas if I use these async tools, that one user, well, they see a wait. They know they're going to see a wait because they're running something expensive. But everybody else still gets their data quickly. That's my goal. Does that make sense? I don't want everybody on the website to be slowed down because one user is doing something. Now, we won't be doing too much with async right now. We'll get into this next week because we don't have databases yet. So all the stuff we're doing right now doesn't touch a database, so it's not really slow. However, we can still do a little bit of a test with that. So I'm going to go pull back this example I have here. Actually, I'm going to just pull up the code that they gave me with the book. Okay, so we have this one page here. What this page is doing, it's going to go download the APRESS website. Going to go grab the APRESS website and then send it back, and send back how long is that document that it got back. How many bytes long is it? Okay. So let's run this. Oh, okay, they're showing you the old syntax. Let me do something that's going to be more insightful. So add another controller. Actually, let me do that over here. Controller, add controller. So operation, controller, add. Okay, so when it's done, it's just going to return done. So this is milliseconds. I'm going to tell it to sleep for 10 seconds. So we can expect that whatever this operation is, if I try to pull up this page, I know it's going to take 10 seconds to run. So this page is fast. Slow operation. 1, 1000, 2, 1000, 3, 1000, 4, 1000, 5, 1006, 1000, 7, 1000, 8, 1000, 9, 1000, 10, 1000. Should be any time now. There. Right? So that took a long time to load. I'd expect, we know that. If I try to go to the main page, so I can get to the main page fast here, let me start this. Oh, I don't have to. So that's that. It's actually not slowing it down. So if I want to run this asynchronously, what I need to do, there's a few things I have to add. So write an asynchronous method. I need to first mark that as async. And then I need to say this returns a task string. So every async method always is async and then task something. That's how you have to start it out, okay? So if I wanted to start that out, that yeah, I'm gonna go run with the one we have. So let's go run. So let's say we want to run here. They've got something that takes some time. Pull this up. There it is. I'm going to create a client. I'm going to say grab a message, grab that from there. System.net HTTP. That's what I'm missing. Oh. I am missing a dependency. System.net, HTTP, add reference. There. Something else I have to install. There we go. Okay. So create a light client. I'm going to ask for it to say do thing. So this is kind of what the book is showing. Hey, this is the old way you would have done this. This is the old way to do it with pre the async and the pre the async keywords. There's a lot of stuff you had to do. Let's just skip on to this because you've never seen the original. So wait. When I'm done there, I want to just return this. There we go. So first thing, I create a client, which is going to create this kind of connection to go out to the internet. And then I'm going to say, okay, go grab this website, save it. We're going to wait for it to be done because this method itself is also async. Get async is async. So we wait for it's done, and then when we're finally here, we can say return it. This needs to be long. This contact length is long. So this is how it normally works out. We have the async keyword. We go do something that's asynchronous using the await keyword to wait till it's done, and then we finally have our operation kind of thing when that finishes.
So what is the await waiting on?
The wait is telling, go to sleep. We're not don't this controller, this action, put it to sleep. We're not busy until it gets done going to fetch this page. That makes sense? So it's going to go fetch that page on the internet, but in the meantime, await says, let's just go to sleep and wait. Let everything else on the server, let them do their thing.
So like if I code after that second line with the await in it, it would execute that code.
So if I didn't put the await here, this would return a task, and I could kind of do some stuff in between. But typically we're going to wait because we need it for this particular user, whereas, hey, some other user wants to do something, right? So the whole point of this await is we're gonna stop and wait so that other users can be served. That makes sense? We're gonna say, okay, go do this. Tell me when you're done, and then I'll come back to you. When your food's done, I'll come and pick it up and do the thing. So this is basically waiting for saying, okay, I've told the kitchen that you want this website, and I'll come back to you when your website's ready for you, when I've downloaded that page. I think that yeah, no, they've removed it. They've removed the non-async version entirely. So that's kind of how it works. Yep.
The long, instead of task. What's the long for?
So this is what we're returning, effectively. Yeah, 64-bit number. You see content length. What does it return? It returns a long question mark. So this content headers, content length is just how many bytes long is the web page that we just downloaded. So that's the type it returns. So we're just saying we'll return that. The way this is going to work out when we actually get to it, it's going to be async task action result. So that action result is going to go between the two task parts. This may not make a lot of sense at this point. That's okay. The thing you want to understand is why we're doing what we're doing. That makes sense. The whole reason that we want to use this async stuff is we want to serve multiple users at the same time. I do want to look briefly. There's another video from this guy that shows a little bit more about how this might work in JavaScript. Let me open up this.
So in the last section, you learned how to build RESTful APIs using Express. But in that section, we used a simple array to manage the list of our courses. Make sure that you folder for this section,
Okay.
async demo. Let's go in this folder and do an npm init with the yes flag.
This is not interesting.
Okay,
for us.
beautiful.
This is just
We
set
have
up
a new node project, and now let's open this folder in our favorite editor. Now let's add a new file, index.js. In this file, I'm going to write a couple of console.log statements. So console.log before and then after. This is an example of synchronous or blocking program.
So this is in JavaScript for those that are unaware. This is JavaScript code that he's writing here. And you could run this in the browser, it would be fine, but he's running on something called Node. So it'll be a little bit different.
In this program, when the first line executes, the program is blocking, and the second line has to wait until the first line finishes execution. So that's why we call programs like this synchronous or blocking. In contrast, we have asynchronous or non-blocking program. Let me show you an example of an asynchronous program. So in JavaScript, we have this function that you should be familiar with, set timeout. This takes two arguments. The first one is a function. So I'm using the arrow function syntax. So let's pass 2000 milliseconds or 2 seconds here. After 2 seconds, the code inside this function will be executed. So I'm going to use this to simulate a call to a database that is going to take 2 seconds. So let's do a console.log, reading a user from a database. So I'm simulating the action of reading a user from a database that is going to take 2 seconds. Now, when we run this program, what do you think we're going to see in the console? Someone may think first we're going to see this message before, then the program is going to wait for 2 seconds, and then we're going to display the second message, and finally the third message. But that's not how this program works. Let's have a look. So back in the terminal, node index.js. See what happened? We have before, after, and then read a user from a database. Also, what is more interesting is that before and after are displayed immediately, and then we have the wait of 2 seconds. Let me show you one more time. So look, before and after, now 1, 2, and here's the third message. So let's see what's happening here. This set timeout function is an example of an asynchronous or non-blocking function. When we call this function will schedule a task to be performed in the future. In this case, 2 seconds after. So 2 seconds after, it will call this function that we pass as the first argument. So when we run this program, first the first line is executed, then we get to the second line. Now all this function does is scheduling a task to be performed in the future. It doesn't wait, it doesn't block, it just schedules a task, and then the control is returned. So then we'll get to line 5 and display this after message in the console. So that's why when we run this program, first we see before, then immediately after we see after, and 2 seconds later, when this function is executed, we get this message about reading a user from a database. So this is the difference between synchronous and asynchronous code. Now, one thing I need to clarify here is that asynchronous does not mean concurrent or multi-threaded. In this application, in this program, we have a single thread. So our single thread first executes the first line, then schedules a function to be called in 2 seconds. Next, it will display this message in the console, and after that it will be free. So in 2 seconds from now, it will execute this function and display this message on the console. Earlier in the course, I gave you a metaphor. Remember this imaginary restaurant? So in a synchronous restaurant, when you get a table, the waiter comes to you, takes your order, gives it to the kitchen, and then sits there waiting until your food is ready before moving on to the next table. This is an example of a synchronous or blocking restaurant. In contrast, in an asynchronous restaurant, the waiter doesn't wait in the kitchen. So while the chef is preparing your meal, the waiter will move on to the next table to take their order. What is important here is that we have a single waiter or waitress. This is like a single thread in a program. So we don't have multiple threads. We don't have concurrency. Now, why do you need to know all this? Because in Node programs, whenever you're dealing with an operation that involves disk or network access, you're dealing with asynchronous code. So you need to understand how asynchronous code behaves, and more importantly, you need to know how to write asynchronous code in a clean and maintainable way. And that's what you're going to learn in this section.
So that's kind of a quick introduction of how things look over there on that world. We'll have all of those kind of pieces where, hey, at some point on the ASP.NET site, you want to read maybe from disk, read from database, read from another website somewhere out there, right? All of those cases are things that take time. So we don't want to hang up any of the other users for that, and we want to understand that things might necessarily, when we get into asynchronous code, whether it be on the JavaScript side or whether it's on the C# side, things don't necessarily happen from top to bottom. Does that make sense? That's the big thing that you're going to see. Things don't always happen from top to bottom. This line, then that line, then that line. It's like, we'll call this function later, and then keep going with the rest of the program. Okay. That's everything in chapter 4. Seeing as we're at 3:30, I know that I'm not going to get done for sure with chapter 5. I do, maybe I'll look at and see. Yeah, so I'll just push that off I'll just push off chapter 5 for tomorrow. Because we're not going to get, I don't think we can get far enough into it to make sense to start with it today. Just to kind of review the things that we've talked about today. So we talked about auto-implemented properties, right? What's the upside of using auto-implemented properties over actually implementing the properties completely ourselves?
Yeah, you don't have to repeat code as often.
Okay.
That's what I was about to say.
I don't have to write as much code, I would say. I don't have to write as much code to implement those properties. So it saves a lot of that extra code writing. That's the big thing. What about object initializers?
It makes it easier to account for all the properties.
Can I ask you to raise your hand before you speak?
Yeah. That's fine.
Just because I'm trying to get input from everybody in the room. And if you talk before I get hands raised, then it's harder to get
That's fine.
everybody a chance to talk. Okay, so what were you going to say?
I was going to say it makes it easier to account for all the properties without using a constructor, or use some more versatility when you're initializing an instance of an object.
Esm? Why might what's an object initializer? Why might I use it? Object initializer. What is it? Why might I use it? Scott?
You mean like instantiating
Okay.
an object?
Instantiating an object. That's one place I would use it. What are my options when I'm instantiating an object? So I can use an initializer. I can use something else. What's the other thing I can use? I can just set properties, right? I can use setters, or I can use the initializer, right? They do the same thing. There's no difference in performance or anything. It's purely on the code that we write. So what's the difference between those two? Between an initializer and just setting the properties directly?
Because it's all in one spot.
That's related.
You know, like,
So, two benefits. I have to write a lot less code. Just like the point of auto-implemented properties, I have to write a lot less code. Okay? It means I have to write less code. It means it's more readable because yes, it's kind of all in one block. So less code, more readability. Those are the reasons we're going to use it over that. What about collection initializers?
Just had a question on object initializers. So
Yes.
if a class needs to have arguments passed to it for a constructor in order to initialize it, then should you not use the object initializer?
You should do both.
Okay.
You can do both. So let's say I have a constructor that needs a parameter. So new, I'm going to make a thing. And in order to construct a thing, I have to say in order to construct a thing, I need some number. And then I want to set an additional property. I can do both. So I call the constructor and also use the initializer to set additional properties. I can combine both of those things.
Okay.
Does that answer the question?
Yeah.
So I can do both of those things. But the upside of this as well, notice when I'm calling these things in the constructor, I'm passing them by order. I have to know what order they come in and what they are. Versus if I'm passing in the initializer, I'm saying the name of what I'm setting, right? If I'm looking at this, I have no idea what this 5 represents. I know that wrench is the name, but I have no idea what the 5 means.
But you do lose
Right.
implementation hiding, it looks like, since you would have to know the name of the properties.
I have to know the name of the property, but I know just by looking at this file that you're setting the name to wrench. But I don't know what you're doing with the number of 5. I have to go look at the thing class and figure out what that 5 means. Does that make sense?
Yeah.
It's not implicitly here stated. And if at some point in the future you changed what that number means, does this file automatically get updated for the new meaning? Probably not, right? So it's still sending 5 even though 5 means something else now. So yes, you can do both, but we'd strongly prefer to just do the initializer and leave off as much as you can, not have a constructor as well. Does that make sense?
Yeah.
But you may need both. It does happen. What about collection initializers?
You did create a list in an array?
Okay, create a list array. I said the benefits of the object initializer were 2 things. What were those 2 things?
Less code and easier to read.
Yes. Okay. Same thing applies to collection initializers. It's the same reason we use them. Less code, easier to read. Okay. Lambda expressions. What's the point of these lambdas?
Less code also.
Less code, sure, yes. Because if I had to write out a full function every time I want to use this, say, x arrow x.price, or a function for every one of those, well, that would get pretty expensive. I'd have a lot of functions I was writing. I'd have a, I'd probably end up with a controller that's got 100 methods on it, easy. And then I'm like, how do we manage that? Well, write a lambda. That way, because the other thing is if I write a method, right, I've got to then stuff it somewhere else. I've got to go stuff this somewhere else instead of where I'm using it. If I use a lambda, it's right there. Where I'm using it, I know the context that it's in. Okay? Graham, I think you had your hands up.
Yeah, it says it simplifies the use of delegates too.
Mm-hmm. Because delegates, remember, they're just a type for, we're giving a strict type for functions. A delegate is just a function object, basically. So it's a quicker way to instantiate a delegate, if that makes sense. Because I can do it in one line versus having to write a whole function. Okay? The var keyword, what's the point of that? Could I write all my code without the var keyword?
Yes.
Not with lang, probably.
There's one specific thing I have to use that var keyword for. One specific feature that we talked about. It does come up in length, but it's one specific one that we talked about. Remember anonymous objects? If I create an anonymous object, I have to save it in var. Right?
Because then it won't be anonymous.
Because I don't, well, the point of it being anonymous, I don't have the name of the type. Right? I don't have that that type does not have a name. So I need to put it in var because I don't know what the name is. Okay. So if I'm using anonymous objects, I do need the var keyword. Everywhere else I can just put the actual type in there. Does that make sense? As long as I'm not using anonymous objects, I can just put the actual name of the type there. Okay? Now there was a different keyword that I brought up that's similar to var. What was that?
Dynamic.
Dynamic. What's the difference between dynamic and var?
You can change the type
Of
the variable, or was it not variable?
So if it's dynamic, I can change the type of the variable.
Yeah.
That's right.
Yeah.
If it's var, it's still strictly typed. I can't put an integer in a string variable or a string in an integer variable if I'm using the var keyword or if I'm specifically saying the type. But if I say dynamic, that type of the variable can change. Now, what's one downside of that dynamic keyword over using the var keyword? Brandon. What's one of the downsides of using the dynamic keyword over using the var keyword? Caleb? Hey Caleb? What's one of the downsides of using the dynamic keyword over the var keyword?
If you need to keep a certain variable, a certain type, you can't do that.
That would be one. But more specifically, there's a better answer. There's kind of two better answers that I'm looking for. Anybody else?
Dynamic uses a ton of processing power.
Not a ton.
Well, a substantial amount more than you would if you were being more strict with your type.
It does use more because it has to do some type checking stuff.
Right.
It has to do some type checking stuff that it wouldn't have to do otherwise. And it has to do that, if it has to do type checking, can you guess what else I might have to do in there? Huh?
Change the amount of memory space.
Mm-mm. That's not what I'm looking for. So if I don't know the type, I usually have to cast. Remember, I usually have to cast it like ViewBag. If I put in the price there, well, I don't know what type it is anymore. It's dynamic. So anytime I want to use that, now I have to cast it down to a double, right? Or whatever type it is. So it means I have to do a lot of casting, a lot of specific, explicit casting to say, we'll cast it to this type. So it means using dynamic oftentimes means I've got additional work that I have to do with additional code I have to write for casting it, as well as there's a performance cost because of all that. Does that make sense?
Yeah.
Okay. Anonymous types. We did just talk about those briefly.
Simplified data storage.
So here's an interesting thing. I can't actually store an anonymous object because I actually need to know the class or the type to store it. So I can't actually store it. I can't send it to view and I can't store it. Right? So the whole point of anonymous type, though, is let me create an object without having a class. The thing to remember there is they're only used as intermediate work, right? I can start by doing that and pulling it from the database using an anonymous object, or pulling it from an array using an anonymous object. But once I want to save it or show it to the user, at that point I have to make it an actual object that I have to build something that I know the type of. Does that make sense? So I have to usually do I'll create that thing, use it, turn it into something else, and then the final result is what I actually save or use. Okay. Link extension methods. We talked about using link extension methods. I hope you're all going to go print out page 89. Please do. And I'll try to give you that handout before you guys leave if I can track it down. And then we talked a little bit about async await. We didn't go very deep into it because we're not really there yet. But what was the main reason that we talked about these asynchronous methods? Essen? Multiple people at once, right? Same time.
Yeah, I was gonna say, right.
Yeah, so handle more people. Caleb, you had your hand up?
To make the whatever you're working on run faster.
Yeah, effectively that's it. The point, the thing to know though about the async, it doesn't actually speed up any one person's request by themselves, okay? So if I just have one person using my website, there is no difference between async and synchronous. They'll both run the same speed. Where the difference is, because I'm running asynchronous, this person's slow operation doesn't slow down this person's fast operation. Does that make sense? That's the difference. It's this person, it only comes in when you've got at least 2 users on the system.
I just had a clarification for the extension methods.
Mhm.
The deferred means that it doesn't execute until it's needed to be executed. Like
Correct.
okay.
Correct.
Just clarifying that one
Yeah.
column.
Deferred means it waits. Deferred means it's wait until you really want your result.
So
right.
like you use like your for each, for example.
So if you use a for each loop, at that point it'll be run. Or if you run a method that's not deferred, at that point it won't run. So if I say first or default, or if I say toList, those are the 2 most common ones. As soon as I say that, it's going to run it.
So the deferred ones have the async built in them?
Again, it's not async, it's actually the iterator. So it's the iterator. It behaves in sort of, it looks almost async. It's not actually, but it's an iterator. Because iterators and async have some differences, kind of some caveats between how they work. So,
Now would be a good time for a break.
yes, now would be a great time for break. Let's go ahead and come back at 4:05.